Hello, students. Today it's section 6.3, Introductions to Polynomials. It's a pretty quick section, so let's get a good look at it. So we're going to be able to define what a polynomial is. We're going to be able to classify a polynomial as monomial, binomial, trinomial, or a polynomial with more than three terms. And we're going to be able to evaluate a polynomial for given values of the variable. So let's go. A monomial in X is a term of the form kx to the n, where k is a constant, it's the coefficient, x is the variable, and n is the whole number integer. Okay, notice it says, the whole number. Notice that it's not an integer. In other words, in a polynomial, we cannot have negative exponents. It must be a whole number. Whole numbers are only zero and counting numbers, okay? N is also called the degree of the term, and k is called the coefficient. So let's look at this. So a polynomial is a monomial, or the indicated sum of differences of monomials. The degree of a polynomial is the largest of the degree of its terms, and the coefficient of the term of the largest degree is called the leading coefficient. So let's look at these. Here are some examples of monomials, binomials, and trinomials. Let's look at the root. Mono meaning one, bi meaning two, and tri meaning three. So a monomial will only have one term. For instance, a negative 2x to the third is just a one term. 4a to the fifth is just one term. A binomial, though, will have two terms. In other words, it's going to have a plus or minus sign in between it. So 3x plus 5, so here's term number 1, here's term number 2. And a squared plus 3, here's term number 1 and term number 2, I mean. So that makes it a binomial. A trinomial will have three terms, 1, term 2, and term 3. And in between each term will either be a plus or a minus sign. Here's another example of term 1, term 2, term 3. Notice that they are in what we call descending order. The exponents begin to get smaller, 3, 2, 1. Remember, if there's nothing written, there is a 1. All right. So simplify each of the following polynomials by combining any like terms. Write the polynomial in descending order and state the degree and type of the polynomial. So first thing is we're going to combine like terms. So let's look, are there any like terms? Well, if their base variable is the same, x, and their exponents are exactly the same, then they are combinable like terms. So since these are both x to the third, we can combine them by just adding their coefficients. So we get 12x to the third. And now, how many parts are there to this? There's just one. That's why it is a monomial. And degree 3, I get the degree right here. This 3 is the third degree. So we have simplified it. It's in descending order, and we stated the degree and type of the polynomial. Here's a second one. Combine any like terms. Well, here's an x to the third. Here's an x to the third. So that's going to give me 12x to the third. But this is not the same. It does have an x, but it's not x to the third, so I cannot combine it. So it looks like this. This then is a one part, two part. So it's a binomial. And still look at its leading degree or its leading coefficient, leading term, its degree is 3. So it's also still a third degree binomial. Let's go ahead and try this one. This y and this y would combine, right? So it would give me 3.5y. And then, which is the same as 7/2. 1/2 plus 6/2 is 7/2. That's where this comes from. Why did this go into the second place though? And this is first, well, let's look at the degree. The degree is 2 to 1 to 0. There's a 1 here, and then there would be a 0 here. And so it's descending. That's what they wanted. If I look at it, how many terms? 1, 2, 3. So it's a trinomial. And if I look at its degrees, the highest degree on that leading term is 2, so it's a second degree. Okay, this one we got to collecting like terms. x squared minus x squared, those just cancel out. And I'm left with 8x minus 15. So this is a 2 terms, so it's a binomial. It's only got a degree of 1, so first degree. Its leading coefficient just happens to be 8, just to point that out. And it is in descending order. Okay, E, let's see. I've got a y to the 4th, y squared. And uh-oh, alarm. Ooh, ooh, ooh. Remember, a polynomial cannot have an exponent with a negative. So this is not even a polynomial. We would just say not a polynomial. So when you see that negative term, nomial, you're going to say that it is not a polynomial because it has a negative exponent. All right, and here's our one. Now, evaluate really means to solve, or remember when we were doing functions and I would say, that's basically what we're saying, p of x. What would p, or in this case, this would be our y value, right? What would y be if x was 3? So we put a 3 in there. Wherever there's an x, put a 3. And we come out with 36. So we actually now have the ordered pair, 3 and 36. Because remember, this is function notation. It really just means y. And so when it says to evaluate, you're looking for the other half of the ordered pair. When you see that clue word, and generally they give you x, and so you're always looking for y. So what would y be if x was a negative? Oh, in this case, what would, now we're just starting to play with different variables everywhere. So what would this function be, the value here in our thing, if the y value was a -2? So now you're not thinking of it as in linear pair, because we're now dealing with polynomials and we're going to use all sorts of variables in its position, okay? So what would the function be? That's what we'll say. What would the function be if y was a -2? So we put a -2 wherever there's a y. We do all the math. And we end up with a -22. So it's the ordered pair, a -2 and a -22. Okay, so we are going to practice. We're going to combine like terms and state the degrees and types of the polynomials. So any like terms? Well, there's nothing with 8x to the third, so I'll write that down. That's taken care of. -3x, oh wait, there's a -x to the third here. So actually that's going to be 8 minus 1 is 7x to the third. All right, now 3x, a -3x squared and a positive 3x squared. Well, they're just going to cancel out and be zeros. And then what's left is a +5. So this is a binomial. And its degree, look at the leading term. Its leading term is 3. All right, let's do this one. I have 5y to the 4. Any other y to the 4? Yep, right here. 5y to the 4 plus another y to the 4. That's 6y to the 4. I'm going to cross those out because I know I've taken care of them. -3y squared plus 2y squared. That's just going to be -y squared. Taking care of them. And +4. Oh, this has got 3 parts. So this is a trinomial. And its leading coefficient is 6y to the 4th. And so the degree is 4. Okay, for the polynomial of p of x equals x squared minus 5x minus 5, it says find, in other words, evaluate or find or solve. What if the x value was 3? So if I put 3 in here, 3 squared minus 5 times 3 minus 5. So 9 minus 15 minus 5, that's going to be a -11. That's for A. There's a 2-part to this. And the B part says, what if we put a -1 in there? So a -1 squared minus 5 times a negative 1 minus 5. Well, negative 1 squared is 1. Negative 5 times a negative 1 is plus 5 minus 5, and so I actually get 1. And there we go. All right. Good luck on just identifying them and evaluating. I think you can do this quite well. You guys have a good day, and we'll learn more in our upcoming video.